Hello everybody, welcome to Ahead Dental Academy. My name is Dr. Nitin Kumar Singh. I am an MDS in Operative and Endodontics. Today I will be discussing a very important topic by name dental amalgam. This is an important topic from BDS first year and final year examination point of view. Many of the time you get short notes on this topic. Now, in this topic, let's first discuss about the various terminologies. The first terminology is amalgam. Now, what is an amalgam? It is an alloy containing mercury. We normally mix the alloy and the mercury, and after mixing, the thing which is formed, that homogeneous mass, is what known as amalgam. Now, what is a dental amalgam? An alloy of mercury, silver, copper, tin, which also contain palladium, zinc, and other elements to improve handling characteristic and clinical performance. That is what a dental amalgam is. Next is your dental amalgam alloy. Now, a definition by alloy, what it says, an alloy of silver, copper, and tin that is formulated and processed in the form of powder particle or compressed pellets. Basically, we all have used amalgam. In that, what we use an alloy and mercury. The alloy which we use is what known as dental amalgam alloy, and the mass which is formed after mixing dental amalgam alloy and mercury is what is known as dental amalgam. Now let's discuss about the indications of amalgam. The first and foremost indication is the class 1 and class 2 cavities, that is of moderate to large size. If a cavity is small in size, composite is the preferred restorative material, whereas if the size of the lesion is moderate to large, then amalgam is the choice of restoration. It is also used for core buildup. It can also be used for the cuspal restoration as a dye material. Also, we can use it. We can also use where there are very heavy occlusal contacts, especially in the cases of molars where there are such a heavy amount of forces and the size of the cavity is what moderate to large of the size. In those areas, amalgam is the ideal restorative material. Again, in the area where isolation cannot be maintained, as we all know, composite is an hydrophobic material. So wherever we are not able to maintain isolation, in those areas we cannot do composite. However, amalgam, again, while doing amalgam we should ideally maintain isolation, but amalgam is not a hydrophobic material. So where 100% isolation cannot be maintained, we can use in those areas amalgam. In teeth that act as an abutment for removable appliances is also an indication of your amalgam. In the class 3 cavities, in the anesthetic areas, that is the distal surface of the canine, which is not especially visible when the patient is smiling, again we can do dental amalgam. In the class 5 lesions, again where aesthetics is not the prime concern, again we can go with your dental amalgam. Talking about the contraindication of amalgam, it is contraindicated in anterior teeth where aesthetic is of prime concern, aesthetically prominent areas of posterior teeth, small to moderate class 1 and class 2 restorations that can be well isolated. In these cavities, composite is the ideal restorative material. Again, small class 6 restoration is again an contraindication. Let's discuss about the composition of the dental amalgam alloy. So this is the composition of your dental amalgam alloy which we use modern days. It consists 69% of silver, 18% of tin, 12% of copper, and 1% of zinc. This is the composition of modern amalgam alloy. Now let's discuss about the various components which are there in your dental amalgam alloy. The first and the most important is your silver. The primary function of silver is to increase the strength. So this is a very important point. Silver increases the strength of dental amalgam. It also have other effects like it will going to decrease setting time, and it also decreases the tarnish. Next component is your tin. it improves physical properties when compounded with mercury. Sorry. Now let's discuss about the role of various components of dental amalgam alloy. First is your silver. Silver increases the strength of the restoration, which is the primary function of the silver. Other effect is like it will going to decrease the setting time, and silver also reduces the tarnish of the dental amalgam. Next component is the tin. Tin improves physical properties when compounded with silver. Other effects are it will going to reduce setting expansion, it will going to reduce the strength. Copper. Copper increases strength, increases hardness, reduces corrosion. However, the other effects are like it will going to increase setting expansion, it will going to decrease creep, and the last component is the zinc. It is reduces oxidation of other metal. Basically, it is a scavenger of oxygen. However, other effects is like delayed expansion with moisture contamination. As we all know, if an alloy contains zinc, and when we are mixing the amalgam and when we are putting in the cavity, if during the condensation of the amalgam, if water, that is the saliva, comes in contact, then zinc react with the water and result in the formation of hydrogen gas, which will be reason for the delayed expansion of the dental amalgam. Now the alloy which we use, they can be either of two shapes. Either it can have a lathe cut shape or it can have a spherical shape. Right now in this SCM picture, what you can see, the lathe cut alloy. Now how these lathe cut alloy are formed, basically what the manufacturer do, they take all the constituents like silver, tin, copper and zinc, and then they heat them to form a liquid mass, and then they are going to do what, homogenizing treatment, so that all the components are become homogeneous in that liquid mass, and then they cool it very slowly to form an ingot. What you can see is the ingot of dental amalgam alloy, and then this rod, what you can see right now, is fed to the milling machine, and then these, by the milling machine, they cut it into lathe size particles, which can be further grinded by doing ball milling, and then these alloy may be acid treated, or they can also, manufacturers also do stress relief treatment to relieve the stresses which are incorporated during the milling process of these alloy. Next, what you can see is what the spherical shape, how the spherical shapes are formed. Basically what they do, as the what the manufacturer do, they incorporate all the component, melt them and form an homogenizes mass, and then these liquid mass is sprayed in an inert environment in a chamber. If the alloy falls down before hitting the wall, then the spherical shape of the alloy is formed, which can again be acid treated or can be heat treated to reduce the stresses inside the alloy. Now let's discuss about the classification of dental amalgam alloy. Based on the particle size, it can be lathe cut, it can be spherical, or it can be a mixture of both, known as admixed. Based on the copper content, it can be low copper or high copper alloy. Low copper alloy less than 6%, high copper alloy more than 6%. Normally between 13 to 30% is the copper content. Based on the zinc content, it can be zinc containing or non-zinc containing. If less than 0.01%, we call it non-zinc containing. If more equal to 0.01 or more than 0.01%, we call it zinc containing alloy. Now this is a very important chart. What you can see right now, the different phases of amalgam, like gamma phase, gamma 1 phase, gamma 2 phase, epsilon, eta, and the silver copper effective alloy phase, and various their stoichiometric formula. Gamma is what? Silver tin phase, Ag3Sn. Gamma 1 again silver mercury phase, Ag2 Hg3. Gamma 2 phase, Sn7 He. Epsilon phase, Cu3Sn. Eta phase, Cu6Sn5, and silver copper effective, that is AgCu. These phases are very, very important. In low copper and high copper, some of the phases are there. So in high copper, some of the phases are absent. When their chemical reaction do happen, some of the phases form, some of the phases are removed. So this chart is very important to understand what is the chemical reaction that occurs between the dental amalgam alloy and the mercury. Talking about the manipulation, we can manipulate the dental amalgam in two ways: by man, that is what, by doing mortar and pestle manipulation by mortar and pestle, or you can also do by your, sorry. Now let's discuss about the manipulation of dental amalgam. There are two ways of manipulation, either by mechanical means, that is by mortar and the pestle, or by the amalgamator. In the mortar and pestle, what we do, we take the alloy and we put mercury and we mix it with the help of pestle. And after mixing, what we do, we take the mass and put it in our hand, in a glove finger, and by doing just with the thumb, we make it in a more homogeneous consistency. Or we can repeat the same thing. What we can do, we can take the rubber dam sheet, in that we can put the alloy, and then we can do the rubber dam sheet like this, and then a homogeneous dental amalgam will form. This homogeneous mass which is formed because of doing either between the rubber dam or between your hand and your by finger is known as mulling. This mulling will result in uniform coherence mass, which is quite easy to condense. Now other way of mixing is by the amalgamator. What you can see is your amalgamator. Here what you can see, your amalgam capsule. This is the last photograph of your amalgam capsule. In the amalgam capsule, in the center there will be diaphragm. On the one side there will be mercury, on the one side there will be alloy. So both mercury and alloy are in the ratio of 1:1, and this is known as what, your Ames technique. In this, what is there, basically equal amount of mercury and alloy is there. What we do before putting in the amalgamator, we just what, do pressing of the capsule, which will result in the fracture or the rupture of the diaphragm, and we immediately put in the amalgamator and start the amalgamator for 20 to 30 seconds. This will result in the more homogeneous and proper mixing, and this will result in the minimal mercury in the mass, which is also known as minimal mercury technique, also known as Ames technique, resulting in 1:1 ratio of mercury and alloy. So after mixing, and when the full mercury and alloy mix and sets, it result in the final setting and result in the formation of this homogeneous mass, which consists of 50% of mercury, 25% of silver, 15% of tin, 8% of copper, and 2% of other metals. Right? So 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 it consists of 50% of mercury, 25% of silver, 15% of tin, 8% of copper, and 2% of other metals. So I hope this session was quite useful to you, and in my next video I'll be discussing about the chemical reaction that happens between the mercury and the alloy. For any further inquiry and the help, you can call us on the number given below, or you can straight away mail us also. We can try to reply you as fast as possible. So bye for now. Thank you.